I think most people just care about like the experience of using it. And so I see this mistake made a lot when people are building, especially in the decentralized space or even like in cryptocurrency world. You see this a lot where people are making stuff that's so hard to use that they only get the true believers, the really ideological people who would use it no matter how terrible and hard it was to use. Everyone else who's not really that bought into the ideology of, everything needs to be decentralized or everything needs to be whatever the buzzword is. Those people are not going to be sold by it. Like if you're making a Twitter clone, for example, but it's decentralized, but it's 10 times harder to use than real Twitter. You're not going to get any normal people to use it. So that was the thing I wanted to be really careful when we were building Wormhole that we didn't do. I didn't want to be like, this thing is worse in a lot of ways, but it's most secure and try to get people excited about that. It has to be better even if you don't care about security.
Big thanks to our partners Linode, Fastly, and LaunchDarkly. We love Linode. They keep it fast and simple. Check them out at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com and get your feature flags powered by LaunchDarkly. Get a demo at launchdarkly.com. What's up, JS Party people? Have you ever wondered if you could be offering a faster, less buggy experience for your customers? Well, with Raygun Error and Performance Monitoring, you have all the information you need at your fingertips to quickly find and fix errors and performance issues across your tech stack down to the line of code. This saves you time, this saves you money, and this saves your sanity. Head to raygun.com to join thousands of customer-centric software teams who use Raygun every single day. Again, raygun.com to give them a try with a free 14-day trial.
This is JS Party, your weekly celebration of JavaScript and the web. Save the date, August 19th is our next live recording of Front End Feud. We'll be pitting two of your favorite web dev podcasts against each other. Can you guess who? Fill out our form at jsparty.fm/ff so we have enough data and give yourself a chance at a free JS Party t-shirt. Okay, let's do this. It's party time, y'all. That's right, friends. It's JS Party time. I'm Jared. I'm your internet friend, and I'm joined by a few of my internet friends, Adam, Nick, and special guest, but also regular person, Ross. What's up, guys?
Regular person.
Hoi, hoi.
Hey, how's it going?
What's up?
It's going very well. So for Ross, Adam, Nick, and I are here to grill you on Wormhole. So unlike the rest of us who just talk about technology, you actually build technology and launch it into the world. Just kidding, Nick. Nick, you do stuff.
You can't prove
and we like to bring you on to talk about the stuff that you built because it's always JavaScript based, it's always web based, it's usually interesting. We've done a show with you about BitMidi back when you built that. I think we did a show about your annoying website as well.
Yeah.
We talked about Virus Cafe, which I think you renamed because we all said, hey, this is cool, rename it. It's called Speakeasy now. And now you're back with Wormhole. So let's dive into it. Tell us what Wormhole is and we'll go from there.
Yeah, by the way, thanks for always having me on to talk about whatever I'm building. It's always good fun.
It's fun.
It's like JS Party is like the first stop on my way to launching anything new.
There you go.
So
happy to do it.
Yeah, or changelog, I guess, because I think maybe one or two of those things you mentioned were on changelog.
I think BitMidi was on changelog.
Yeah.
And
we've done WebTorrent as well, so I didn't list all the things. But
That's
yeah,
true.
we always like to talk to you because, I mean, it's cool because there's context, there's reasons why you build these things, but also like you're usually building with interesting technologies and like kind of pushing the edge of the browser. And so it's interesting, I think, just both to see what you're interested in, what you're building, but also the how, I think is very helpful, especially for those of us trying to build cool things, just to get the inspiration of like what you can do with web apps. So tell us about Wormhole.
Yeah, totally. Yeah. So the goal of Wormhole was to be the fastest way to send files on the internet. So the way it works is you go to wormhole.app, you drop some files on the page, it encrypts them with a key that's generated in your browser, and then it sends the files to your recipient. So you get a link, you can send the link to them however you want. And that's basically it. The trick is it's really fast. So, as soon as you drop those files on the page, the link shows up and you can send it to your recipient even before the files have finished encrypting or uploading. And your recipient can just click, to download them. And it uses streaming, which means that, you could be like 1% uploaded and they'll be 1% downloaded. It's sort of like they can start to download it right away before it's finished, which is something that I think is pretty unique as far as file transfer services go. And then the end-to-end encryption is the other part that's really unique. So we designed it in a way where we can't see your files. We don't want to see your files, and we do everything in the browser on your end. So you're encrypting the files, and then the link that you send to the recipient contains a decryption key, which they use to decrypt the files. And it's all done in such a way that the server never sees the key at any point. So there's no way for us to do anything with your files, even if we wanted to. And that's kind of Wormhole. That's the TLDR.
Yeah.
I'm curious how that works. Could you break that down for me a little bit of how the URL contains the key and I send that to somebody, and then how do they request the file without sending that piece of the key? Like, is it broken off in the front end of the recipient, or how does that work?
Yeah, that's a great question. Because, your first reaction would be that, well, okay, when the recipient clicks the link, they're going to make an HTTP request. Their browser's going to make an HTTP request, and that's going to contain the key in it. And so obviously our server would get that request and could look at the key. That's what you'd think. But we're using the hash part of the URL, which is the pound sign or hash symbol. Mm-hmm. And we put the key after that symbol. And what that means is that that's never sent to the server. It's funny, anytime, any app, it's not just Wormhole. This is not like a thing we invented, but it's a common technique when you want to make any kind of app that deals with security. You can put like the key into that part of the URL. And it's totally an abuse of what that, was originally meant for. Like that part of the URL was meant for like scrolling the user down to a certain part of the page. So usually the way it works is the browser makes the request for the URL without everything that comes after the hash sign. And then once the page is loaded, then it looks for an ID, an element with an ID that has like the same name as the part after the hash symbol. And then it scrolls the user to that part of the page. So it's a way to sort of jump. It's like an anchor link thing. Mm-hmm. But it's really handy for creating apps where you want to have some part of the, some piece of data that is accessible only on the client side and not sent to the server.
Obviously, anybody who has that link can get the file, right? It's not so much pinned to my IP address or some sort of MAC ID or whatever. Like, it's totally based upon the link. So if the link somehow gets out there, then technically, it's in the wild, right? Because the encryption or the decryption key is in that link. And so basically trust whomever you give that to. Otherwise, the trust that you're trying to build with Wormhole is broken.
Mm-hmm. Yeah, totally. So the link is like the password. It's like, it's similar to like a way a Google Doc works where, the link is sort of the key into the document. It's totally the same. So if you really care about, if you're trying to send some super secret files and you don't even trust the like chat app that you're using to send the link, then, you think that someone is watching it or something, then you can't send the link through it, obviously. So it is kind of a chicken and egg problem. So what you can do in that case is like take the key out of the URL and send that maybe through another channel.
Right, the mail.
And so that the two pieces are not in the same place.
That's a joke.
Yeah.
Print it out. Because that would be like that still isn't even secure either. But like some other, disconnect the, hey, go get this here, and the, hey, get this here with this key. Separate those messages into two different, conversations, so to speak, as a way you can build in security.
Totally. Yeah. And I mean, some people, it's a very specific model of security that we're going for. It's like, we don't have accounts. We don't have any kind of notion of email addresses. So we can't do things like, confirm who the downloader is by having them verify their email. We're not doing any of that. It's just like, it's really simple. It's just, you get a link, and then the link is, the thing that you need to access the files and to decrypt them.
Yeah.
Yeah.
This seems like a collection of really awesome ideas. One of the ideas that seems to be the best is around the security, end-to-end encryption. I can recall talking to you on Twitter about this, and I even went back to Jared, and I think even on Twitter I outed myself okay, so just because it's SSL doesn't mean it's secure. I didn't really consider what it really meant to be end-to-end secure or encrypted even. I use Dropbox, I'm a Dropbox user, so from that point of view, that end-to-end encryption and security was what piqued my interest, because sure, Dropbox can scan my files, and because of their terms of service, they can share that data with third parties and affiliates. Now, they may not, or they may, I don't know. There's a lot of behind the scenes. Dropbox isn't connecting with me on the daily on what they've done wrong or done right. Those are obviously trying to be in like the most least consumable postmortems ever, right? But this is a culmination of awesome ideas. Instant download because it's peer-to-peer. You got a lot of stuff you're probably building upon your knowledge of WebTorrent and the idea of peer-to-peer technologies, which you've gotten a lot of. But end-to-end encryption it seems like the hallmark here, right? Like, because of this, everything else fits together. Like, it's the glue. Do you agree with that?
Yeah, so I think a lot of people, a lot of companies actually use the word encryption in a way that makes people feel nice and safe and nice and comfy when they see it. They're like, oh, encryption. And in some cases, even, like Zoom, the video chat application, was saying, their app was end-to-end encrypted, which is even better, but it wasn't true. It was actually just false advertising. And so, it's really worth looking into what exactly people mean when they say things are encrypted and to really understand the distinction, and especially even the difference between encryption and end-to-end encryption. So those are not the same. They're not even close to the same type of guarantee for the user of an application. So I'll just quickly explain the difference in case people aren't familiar. So you can think of encryption like a lock, right? And let's take the case of Dropbox. So, Dropbox stores your files. You send them to them over an encrypted HTTPS connection. So eavesdroppers on the network can't see the data. Once the data arrives to Dropbox, though, of course, they can see the data you sent them. And then they promise to store it in an encrypted form on their servers. And the key to ask yourself whenever someone says they're encrypting your data is, okay, who has the key to unlock that encryption, right? So encryption is just a lock. It's just like literally like think of like a physical lock, right? And it's really important when someone's saying, well, your stuff's locked up. Well, okay, who has access? That's the question. Who has the key? Who can open the data? Who can unlock it? And in the case of using Dropbox, right, they have the key. So it's good that they're locking it. It's good that they're not just letting it, sit there unencrypted, but they have the key. And that's really important because a few years ago, back in 2010, Dropbox had a terrible bug in their website that made it so that you could log in to anyone's account using any password. They just forgot to check the password, make sure the password was correct. So any string would let you in to that account. This was a real bug for 4 hours. You could just get into any accounts. And I mean, rumor has it, I'm not sure this is actually true, but someone who had a friend who worked at Dropbox, this is very through the rumor mill at this point, told me that it might have been Drew Houston himself that committed that bug.
It's poetic.
It makes a good story at least, even if it's not true. It's
through 2 people, so take it with a grain of salt. But anyway, that was a real bug that they shipped. And of course, that's only possible, right? Because they have the key to your files. So you're trusting them to do a good job with it. And, most of the time they do. But there's all these risk factors that come from giving that access out to other people. So if your data is encrypted and someone else has the key to unlock it, then, it's not truly fully in your control. And so that's what end-to-end encryption is about. It's about, doing that encryption in a way that you are the only one that has the key. So it happens on your device, the key is on your device, and then now, once you've done that encryption, the data goes across the internet. It doesn't matter what anyone wants to do. They can't access the data. They can't unlock that lock unless they have the key, and you're the only one that has it. And you can, of course, share it with certain people, but by default, it's just you who has it, and no one can see your data. So that's the key difference.
Mm-hmm. Yeah, it's tough to distinguish, but it's it means everything. When you really need that security, whatever it is, I mean, we even have circumstances where, federal agencies can coerce, or what's the word when the government forces you to, go ahead and make use of that key that you have, even though for other reasons your business would never do that, but you can be forced to do that in compliance with government agencies unless you don't actually have the key. It has to be not possible. If it's possible, then it can come back to bite you. But so that's a huge part of what this is. The other thing is you mentioned the speed, and I'll just say the ease of use. For a long time, sending large files on the internet was kind of the world of kind of scurvy, spammy websites where you had to
Still
kind of get. Yeah, I mean, I'm sure they're still out there, but you had to either pay some money to send a file, which always had who are these people? And then there's a lot of email handoffs and redirects, and it was just never straightforward to do until Mozilla came out with their Firefox Send, right? Which was a really cool service that I was glad existed, and they eventually shut it down, and Wormhole kind of came in to fill that vacuum. But can you talk about the why? I mean, you mentioned why Wormhole's different and interesting, but why would you want to build something like this? You have probably 1,000 ideas. Why work on Wormhole?
Well, I was really sad when Mozilla shut down Firefox Send because it was such a nice, simple product.
Yeah.
And I was like, there's no reason that this thing, couldn't be rebuilt and done in a way that is sustainable. And so that's kind of what we wanted to try, was to make a version of it that wouldn't get shut down. And it was also a really nice application of all the tech that I've been working on throughout most of my career. The peer-to-peer stuff from WebTorrent really does improve it even beyond what Mozilla did with Firefox Send. because we can do that streaming that I mentioned. So that the downloader can start downloading right away. The user experience stuff that we did too is actually another thing that, Firefox Send didn't do. Here's the thing, like when you're building a security product, you can either sell it to people as, going into all the security details about why it's great, like I just kind of did with you guys and told you all about end-to-end encryption, right? And then you're going to get some people who are like, oh, you know what? Yeah, that sounds like, I am worried about, people getting access to my files. So I'm going to use this thing that is more secure. But I think most people just care about like the experience of using it. And so I see this mistake made a lot when people are building, especially in the decentralized space or even like in cryptocurrency world, you see this a lot, where people are making stuff that's so hard to use that they only get the true believers, like the really ideological people who would use it no matter how like terrible and hard it was to use, and everyone else who's not really that bought into the like ideology of like, everything needs to be decentralized or everything needs to be whatever the buzzword is. Those people are not going to be sold by it. You know what I mean? Uh-huh. Like if you're making a Twitter clone, for example, but it's decentralized, but it's like 10 times harder to use than Twitter, than real Twitter, right? Like you're not going to get any normal people to use it, quote unquote normal people. So that was the thing I wanted to be really careful when we were building Wormhole that we didn't do. Like I didn't want to be like, this thing is worse in a lot of ways, but it's most secure, and try to get people excited about that. It was like, it has to be better, even if you don't care about security. That was like part of the challenge was like, can you even do this? Like, can you? Because usually there's some kind of compromise when you're trying to increase the security or whatever. Like you're making it harder in some ways. You're making it's like a more challenging from a technical perspective. And sometimes that tech leaks out in a way that the user sees it. Like, oh, and you got to save this key, or oh, you got to, whatever nerdy thing they have to do in order to use it. And so we were trying to do it without any of that. So just like be better, faster, simpler, quicker, get you the link right away, not at the end of the upload, all that kind of stuff. And then hopefully that's like, they perceive that as being, just way better. And then also icing on the cake, it's end-to-end encrypted. We can't see your data, in that order.
What's up, party people? This episode is brought to you by Micro. Micro, aka M3O, is a new cloud platform built for developers by developers. Our good friend Azam Aslam is leading this. And if you're tired of AWS and feeling overwhelmed by the cloud, infinite billing, and an endless sea of docs, it is time for a change. The Micro team is reimagining the cloud for the next generation. M3O is a new developer-friendly platform to explore, search, and use simpler APIs for everyday consumption, all in one place. Get access to the APIs you need in one click and test them right there on the web before using them. Simple, fast, and affordable. You won't get burned by bottomless billing. You top up your account and pay as you go. And right now, they're in early development and building out the first set of APIs, and they're looking for feedback from developers. Sign up and get $5 in free credits. Kick the tires, give them your input so they can build the best APIs you want to use every single day. Learn more at m3o.com. Again, m3o.com. You mentioned your love for Mozilla Send. Did you talk to any of the team around that? Did you see any statistics on the usage of that? I'm just curious, like, how often do people send files without storing them? So I use Dropbox in the sense that I already store my things there and just share them because it's there. Mm-hmm. Less on like, oh, I want to share this file with this person arbitrarily or just out of nowhere. What is the statistics on this world? Like, how big is the send files to other people? Well, I imagine kind of big, but then you got the whole, you might be sharing some, what was that? You said scurvy websites, Jared, or just something like that. Like you might be sending some shady things, who knows? What's Shady's the space like? And, did you talk to anybody at Firefox or Mozilla Send from that team around what they did or what they didn't do or,
I never actually spoke with anyone on the team. I probably should have to learn a little bit more. I wanted to, but never got around to it. Files are fundamentally how data works on all operating systems. Like they're going to be with us forever. But I do have to say though, on mobile devices, they're not really exposed in the same way to the user. So files are kind of dying, in some sense. Like I don't have kids or anything, but I bet if you ask an average kid, what is a file? And if only used iOS or something, they might not even know what a file is. Yeah. That is kind of concerning in terms of like the future of growing for Wormhole. So that's partially why, we're thinking about expanding into other types of things besides files. Like, what if we could do end-to-end encrypted photos? What if you could have a photo library that was really fast and as good or better than other services? But we do everything in your browser, including like the detection of what's, in the photos, all the AI stuff you can do with WebAssembly in your own browser. And then once you've figured out what's in that photo, you can attach that metadata to your photo library and upload that into the cloud. But the cloud never sees what's in that library. So the cloud is just this dumb hard drive that's far away from you that you stick stuff on, but it doesn't actually do anything that involves seeing your data. That's kind of probably where we'll go with it. Because right now files are still used in a lot of places. Like developers, creators especially, actually are using files a lot because they still work with raw video and photos and that kind of stuff, and all the apps it's all on desktop.
You got a large send too. It's like 10 gigs is the max file size right now.
Yeah.
So that's gotta be a thing. Do you plan to be Dropbox-like at some point? What's the horizon? What's the outlook?
Yeah, that's another direction that we're thinking about. So building a drive, like where you can put all your files permanently instead of just what we do now, which is storing them for 24 hours.
Yeah.
Yeah, that's a thing people keep asking for. They're like, I want to use Wormhole for
That's where it takes significant investment, because that's a lot of long-term storage. You got, probably some assurances there, probably some sort of agreement backups that, your files won't be lost, This isn't long-term storage. However, it is, storage in general. So it should stay there and not go away. So there's just a lot of overhead, so to speak, when it comes to storing long-term files.
Not to ask you about a product you haven't built yet, but how would you even do key management with something like that?
That's the thing about the current thing we did is we actually have the easiest problem in the world because, the link is the password. And then, if you lose it, okay, whatever. It was only going to be stored for 24 hours anyway. You weren't like putting your most precious files in here and guaranteeing that, I'm going to download them when there's like 1 hour left or something. It's inherently ephemeral. So it's not a huge deal if you lose the key, or if we lose your files, which we're not going to try to do. But, if we did, it's still not the end of the world. So things get way harder when you're like trying to provide a permanent drive. I think like the model that we would follow would be something like 1Password. If you've ever used 1Password, they have a browser version now, and it does all the encryption, all the end-to-end encryption in the browser. And they have sort of this user experience that they walk you through where you save an emergency kit, which is like a PDF with like a key on it. And they have a combination of the secret key that you can't memorize with the password, the master password that you do memorize. And the two together make this like really strong key. And that's a thing that I think they've done a really good job of like explaining to normal users in a way that it makes sense, but it's also still a pretty smooth user experience. And so if we did something like that offline emergency kit that you print out would be like your backup, and we could hopefully still have a pretty decent user experience. But that is a case where, that's going to be harder to set up than like just making an account with some service and just having them be able to reset your password at any time. Like that is just fundamentally going to be a worse or a harder user experience. But hopefully there's other benefits that make it better. In the case of 1Password, people are willing to put up with it because that's the thing where they really don't want the provider to see their passwords to everything, their banks and their files and every single website on the internet. So it's worth it. So that's kind of the idea. Does that make sense?
Absolutely. Yeah. And I use 1Password and have put up with that. And I don't have to put up with it often, which is great. Like it's pretty much just like, I don't know if it does some kind of like local syncing through iCloud or something between like all of my devices with that stuff, but it's pretty simple to set up, and it's overall like a pretty simple solution to this problem. So yeah, I like it.
Mm-hmm. Yeah. The reason why they do the secret key in addition to the password, do you know why they do that?
Security.
Correct.
Yeah, that is correct. That is actually correct. It's because, in the past, 1Password was purely local on your device. And so even if you picked a crappy master password, in order for you to get successfully, hacked or whatever, someone would have to first steal your database for your 1Password, what stores the files. They would have to steal that database, and then they would have to guess, try passwords and try to break in. So that's like 2 steps, right? But then once they started with the cloud stuff, now they have everyone's databases sitting on their server. And so if your password is hello123, right, that means that they could, 1Password themselves could, if they turned evil, like try all the common passwords, and like hello123 would be very easy to guess. And so to help people who have like terrible passwords, they combine that with a secret key that is like completely long and randomly generated, and the two together like are guaranteed to be strong because the key is guaranteed to be strong on its own. So your password just adds extra.
That's smart.
Yeah. And then the problem with that is
your password's a salt.
Yeah, exactly. Your password's just an extra little bit of fluff at the end of the true password, which is the key. But then you have the other problem, which is that users can't remember the key. So that the app remembers it the first time you type it in. And then you just use your password as a practical day-to-day kind of unlock of the app. So it's a really cool design. It kind of solves all the problems that you would worry about with the cloud service.
And they've been committed to that for a while too. I've been a 1Password user probably, I want to say at least a decade. At least. Probably longer than that. So, I mean, they've been committed to that goal, which hopefully, you and Socket Inc. and Wormhole has a similar aspiration to be committed to this goal of what you're saying here.
Mm-hmm. Yeah.
One more question related to this potential future product, but you're very much web first with this. And I assume that that's kind of an aspirational goal going forward too. So things like that key, like that randomly generated key that, would be attached to your password. If you were going to do something like that, is that something that's safe to store in local storage?
Yeah, it should be. I mean, if it's stored in local storage, then it means it is probably accessible to other apps on the machine, which I guess is a weaker guarantee than I think 1Password might do something like storing it in the secure enclave if your device has some kind of hardware place to store stuff. I'm not actually sure. So that might not be accessible through web APIs. I would have to check. That is a good point. It's probably a fine place to store it, but I'm not exactly sure what guarantees it, how it compares to 1Password. So I'd have to look into it.
I know 1Password has that like 1Password X, which is like just the extension. And maybe that offers some extra security, like being an extension versus just being like a web app. But if not that, then presumably they're storing it somewhere like local storage.
You're right. And they even let you log in like just purely with the web browser without any extension.
Yeah.
And then the next time you come back to log in, you only have to type in your password. So the key is being stored somewhere in your browser storage. Yeah. My general thoughts are if it's good enough for 1Password, it's probably going to be good enough for us because they've been iterating on that for a while.
Yeah.
And so it's really inspiring to see them do it because then okay, well, yeah, I mean, it worked for a password manager, so it's probably a similar threat model as files.
Seems like there's iterative steps you can take between here and there with regards to Wormhole as it stands, which is drag and drop a file into a web app and then copy the link and share it. And what we're talking about, hypothetical future product, which is like a full-on drive, Dropbox end-to-end encrypted replacement with files, in storage. One example would be some sort of a desktop integration similar to what Dropbox does, but not having to store the files in a synced drive. Like you could have a right-click share on Wormhole, and then it would just upload the file that you clicked on, right, and get you that link immediately. And you kind of feel like, I mean, that's when it comes to Dropbox, there's kind of two features there. There's the backup with the syncing across your devices, which is kind of acts as a backup, and then the sharing, the collaboration. And you can get the collaboration pretty easily and make it feel more like something that you're using more regularly, or you could just have a file on disk and right click and share it without having to actually do the crazy stuff we're talking about. Like, not crazy, but the heavy lift of what you're talking about, right?
Mm-hmm. Yeah. Fun fact, we're actually a PWA right now. So what that means is if you're using the right browser, you can install Wormhole as an app on your computer. And if you're doing it on the right platform, because it's not on all the platforms yet, then you can click. Yeah, I know. You can right click and select share on Wormhole, and it'll actually do what you described. So
cool.
Right now, if you're on Android and you install Wormhole as an app to your home screen on Android, then that means it'll get added to the share menu. So anywhere on Android, if you have a file, you can get a Wormhole link from it in a couple of taps.
That is cool.
And on Windows too. I think Windows, if you use Edge to install it, then you get the same thing.
What's the holdup on iOS? Because there's PWAs and there's also ShareSheet integration, but maybe not. Maybe they don't talk to each other.
Don't get me started on iOS.
Or do.
Sounds like you haven't got started on iOS.
Safari on iOS is the worst browser by far for web development, and I'm sure anyone who's who's a web developer knows this. It's just like, not just in terms of support of web features, but just in terms of even bugs, like in basic features that should be working good. It's just a disaster. I don't say this lightly, but it's really bad. Like, as an example, they completely broke IndexedDB in the last version of Safari. Like, literally, it doesn't work. Like, a basic web feature that's been in their browser for like 2-3 years. They just shipped it where if you call open indexedb.open, it doesn't work. Nothing happens. The promise never returns. And then the workaround is we figured out apparently they're doing some kind of lazy loading where the first time you mention IndexedDB in your app, it starts up a process, but it loses that first call that you make while that process is starting up. So anyway, the trick is you have to just say IndexedDB somewhere in your app, like at the top of the file. And then later on, when you say indexedb.open, then by that point, the process has started. And then that second call will work. It's like, what? Like, and then they shipped that, right? I made a fuss about it on Twitter. I'm like, guys, Safari literally just broke IndexedDB. And then like all the Chrome people were like, because they actually have a really good Twitter presence. They were like all in the replies, like, what, are you guys okay over there in Cupertino? Are you doing all right? You'd think a test would catch this, like a basic test, like, does it work? Anyway, so then they fixed it, right? But like, then you're like, when are you guys going to release this? And then they comment on the issue tracker, Apple does not comment on future releases. It's like, okay, so now we're just everyone has to assume this is not going to make it until the next major version of Safari. So we're dealing with this bug for the next year. They just broke a basic feature and they're not going to hotfix it. It's like actively, like, if you had to imagine what could you do to sabotage the web, like, it would not look very different than what Apple is doing.
Yeah.
Like, say you support standards, right? But then actually subtly break them all the time, right? I mean, I'm not saying this was on purpose, but I'm just saying it's not that different in effect, in the effect it's having on the web than if they were trying to sabotage it. I know they're not trying to, but that's just the effect that it's having.
I think when it comes
Anyway,
to tabs, they are doing that in iOS 15. So. I'm running the
Not
betas,
even out yet.
I'm feeling the pain.
Yeah. No, don't run betas.
I've heard, but I have not seen personally myself the tab.
I'm just hoping it's fixed by the time the thing ships. Well, don't get me started on Apple Podcasts because they've completely destroyed podcasts. And there's a bug in iOS 14.6 which destroyed downloads for every podcaster in June and up to now because they haven't released the fix for it. They've confirmed the bug. It basically breaks downloads. So like a bunch of our listeners just aren't getting our shows. And it can be fixed someday soon, real soon. So
I heard that you move fast and break things in the Valley.
Yeah. So anyway, Safari is just, I don't know what's going on there. Honestly,
which is terrible because iOS is so prevalent. There's so many people out there using this really expensive device they think is state of the art, which it is as a device. But then the device is only as good as the software it runs. And in many cases, I replace Apple software for the most part. I don't use Mail. I don't use specific things, and I'm just moving away from more and more of those things. And if you can't trust Safari, which I believe they even gate which browser you can put on the iOS device anyways, right? Like, they're all really based on Safari, even though it's a Chrome.
The rendering engine.
Right, exactly. So, like, there's something in there that's, like, always Apple.
People need to know that, too. I think that's not a widely known fact, but every browser on iOS that is not Safari is just a skin, basically. A skin on top of Safari. That's the way to think about it.
Yep.
It's like a UI on top of WebKit, which is Safari. And so even though when you think you have choice and you're like, oh, I'm going to install Chrome, like, you're basically just doing that for the bookmarks, syncing, and whatever other Chrome, things like that. But you're still getting fundamentally the features that the Apple team decides to ship in their browser, and there's no alternative. And I don't know, it means that there's no competition. I mean, they can just do this. They can just break the browser, and then they can say, we don't have a monopoly on the App Store because you can always make a website. In this antitrust case in Australia, they actually, in their defense, they mentioned that you could use PWAs as an alternative to the App Store. So you can actually, make a website that's as good as an app, they claim. But then they fail to mention that they're also in control of what features you can put into your PWA and what things they're going to support. So they don't support notifications. They don't support like a storage system that makes sense. They just break it randomly. So it's not really a true alternative.
Back to the security, though, I think one of the reasons they make this choice, or at least they claim they make this choice around WebKit and other browsers being formed around WebKit, is usually they'll say it's a security reason, or they're so focused on privacy. What do you think?
I mean, that's a fake reason.
Well, you can't break IndexedDB and say we did it for security, you know?
Well, maybe not break IndexedDB, but maybe you can limit the fact that you can only use WebKit. If for some reason it's a security reason, or it's a privacy reason.
I think it's true. Yeah. I mean, to some extent it's true.
Yeah.
Like if you prevent the kind of the JIT compiler basically is what they specifically prevent. And that's why like no browser wants to ship a browser, because it wouldn't be able to be fast, because the JavaScript engine wouldn't be able to do just-in-time compilation. That's my understanding of why no browsers actually bothered to truly ship their own browser, because it would just suck if they did. By banning that, like, I guess there's like some theoretical security benefit to that. But I would argue that like the true benefit, the true security like in iOS doesn't come from like Apple reviewing things and deciding what code gets in and out of the store. Sure, that is one thing, but like the true benefit comes from the other like 1,000 things that the OS does, like sandboxing the app, preventing the app from just reading and writing files in random places, making it so the app only can touch its own files, and making it so that, all the sensitive APIs have to go through these OS calls that bring up prompts for the user that ask if the user wants to do that before it happens. Mm-hmm. All that stuff happens at the OS level. So even if an app was like malicious, the iOS sandbox would do a pretty dang good job by itself of keeping you safe, I think.
In 2 minutes, let's say, give me an answer on this. If the WebKit / Apple team / iOS team, somebody out there who cares about, let's say, the future of the web and all these things, they were listening, how would you fix iOS to be better, more PWA friendly, better web developer friendly? What would you fundamentally change about the way they're doing things?
I mean, probably faster releases would be the number one thing, because there's all these things that you can see that are master on WebKit, but you have no idea when they're going to be released. And usually that means it's going to be a year. So I think faster releases would help a lot.
Yeah.
And also, I mean, just like deciding, if they want to use the web as like their defense against why they're not a monopoly, then they should make sure that the web has all the features that the native platforms have, or else it's not a true defense. Mm-hmm. So, that's not really a thing that the WebKit engineers can decide. It's more of like a Apple strategy thing.
Right.
But
well, at least they can petition, right? If they care about their jobs, what they're doing, and they have enough passion, they can either keep doing it under that guise or fight back and say, listen, this is the way we have to really open up the opportunities for web on iOS. Mm-hmm. There's a choice there.
Mm-hmm. Yeah, totally.
Well, I'll just quote Steve Jobs when he said, "We have a very sweet solution for you. They're called web apps." Remember back before the App Store existed?
Yeah.
And he put that big slide on the screen there, and he said, "Here's our solution for apps on iPhone OS back then." It was really sweet solution, is what he said. Web apps. So for us, they've been committed to web apps before the App Store existed. So I don't know what you're talking about.
Yeah. I don't want to turn this into me ranting only about Safari. I think that the engineers on Safari are great, and they're doing the best they can do with the sort of limitations that they're given by the structure they're in, I think.
Yeah. I think the reason why you got into this position, though, with this, in quotes, rant, as you said, is because we're speculating about the future possibilities of Wormhole, right? We got there by talking about the opportunities of files and iOS and that kind of thing. And so that led us down that road of talking about the different ways you can, utilize Wormhole on an Android device, installed as an app, and the features you get from that, or the flip side, iOS. So, that's where I think we're at. And any entrepreneur is going to have some speculation about the future of the thing they're building. And Jared's question to you is, why are you doing this? And then Nick and I are asking you, what's the long term of Wormhole? Is it going to be Dropbox-like? Is it going to be drive-driven? How could you do that technically? So I think these are all valid concerns, because someone like you who, in my opinion, seems so forward-thinking about the technologies that power the web, you're going to want to push the boundaries. And if you can't push the boundaries on one of the most prevalent platforms out there, then you're going to not do it. And that's not innovation. Mm-hmm.
Yeah, it's definitely holding back innovation. That's for sure. Yeah. I still have an iPhone, which I don't know, maybe
reluctant about.
Maybe I shouldn't. Yeah, no, it is the thing that makes me the saddest about it is the browser. As someone who loves the web, I probably should just get an Android device. But I'm too hooked into the ecosystem that even after all that ranting, I still feel like I still have to have an iPhone. So what does that tell you?
They got you right where they want you.
I do think the WebKit engineers do care about the web, and I think that they are working on it. And it seems like more and more lately, they seem pretty active on Twitter, like talking about things and being open and being on podcasts. They were on a podcast for the changelog, I think, a while back.
Yeah, we've had
which is good.
a couple of engineers on the show, and I've always been very impressed with them personally, both their intellect, their obvious knowledge of the space, and their what seems to me to be sincere desire to make the web better. So that's always
that desire boots up against the services revenue.
Yeah, it does. It totally does.
Yeah, I don't think that it's like the decisions of the team. Okay, so to be fair, there is probably some difference between the way that WebKit team sees the like role of the web. Like I think they're much more in the camp of it should be a document viewer. Not like literally think it should be a document viewer only, but like they're more on that side than like the Chrome team, which thinks that like it should be a super powerful application platform that can access all the device's sensors and do all the things, right? And so you see this in their decision to not implement, like the Bluetooth API or various other like really privileged APIs that Chrome and Edge are fine implementing. There is some philosophical difference there that I don't think is just about resources, to be fair.
This episode is brought to you by our friends at Square. For our listeners out there building applications with Square, if you haven't yet, you need to check out their API Explorer. It's an interactive interface you can use to build, view, and send HTTP requests they call Square APIs. API Explorer lets you test your requests using actual sandbox or production resources inside your account, such as customers, orders, and catalog objects. You can use the API Explorer to quickly populate sandbox or production resources in your account. Then you can interact with those new resources inside the seller dashboard. For example, if you use API Explorer to create a customer in your production or sandbox environment, the customer is displayed in the production or sandbox seller dashboard. This tool is so powerful and will likely become your best friend when interacting with, testing, or playing with your applications inside Square. Check the show notes for links to the docs, the API Explorer, and the developer account sign-up page, or head to developer.squareup.com/explore/square to jump right in. Again, check for links in the show notes, or head to developer.squareup.com/explore/square to play right now.
So we've talked a little bit about how Wormhole works with regards to the sharing of the URL, the key being put in, I think it's called the fragment identifier, after the fragment identifier in the URL. A little bit about how those things work. You mentioned it's peer-to-peer insofar as WebTorrent's involved, but can you break down, like, give us all the gory details, like what technology, JavaScript libraries you're using, from the ground up, how does Wormhole work?
Sure. So we're using a bunch of fun things to make it work. Let's see. Where do I start, though? There's a lot of directions we could go. Let's see.
Are you using TypeScript?
No, I wish we were. No, we actually might switch to it because I'm on a team now with like 2 other people and maybe even growing. By the way, we're hiring.
Sounds like a fun job.
But so yeah, it does help to have TypeScript in those kinds of environments versus like when you're just hacking by yourself. So I'm seriously considering it. So I think if you're familiar with WebTorrent, that's probably a good place to start because that is the underpinnings of the way that the file transfer stuff works. So maybe I'll just quickly explain that for people who aren't familiar. So when you use the WebTorrent library, this is an implementation of BitTorrent. The key idea about how that works is you take a file or a set of files and you want to produce this like torrent file, which is like basically a metadata file. And what's in there is a list of the file names and then their hashes, effectively, like a hash of each of the files is the way to think about it. And what's cool about that is that means now I can share this like metadata file with people and they can now accept file pieces from anybody and then reconstruct them together on their computer, hash the file, and then compare it to the hash that they were expecting. And then if it's the same, then they know that they got the file they wanted. And they don't have to trust the person sending them the file. So we use that for the file transfer part of Wormhole. So what that means is like when you send that link out to somebody, that share link, they're actually downloading the file pieces from your browser and using the whole sort of the torrent protocol under the hood, which means you get like nice behavior like swarming. So if you have like 3 or 4 people trying to download at the same time, then the downloaders can actually share the partial file pieces with each other. And that all just comes for free from using WebTorrent. So it makes it faster, right? It means that like you're not the bottleneck as the uploader sending the same file 5 times to 5 people. You can send like this piece to that person, another piece to this other person, and then they can share amongst themselves, which is a nice, like another little performance benefit. Yeah. So that's WebTorrent. And then we layer on top the end-to-end encryption. So what we do is before we put the files into WebTorrent, before we create that torrent file, we have to end-to-end encrypt the file using a key that we generate on your device. And so for that, we use the Web Crypto API, which is this built-in browser API that lets you do things like generate keys, make secure random numbers, hash things. All that stuff is just built into the browser. We implemented this streaming encryption, and that was based off of the Firefox Send design. We just sort of they made an RFC and explained how this thing works, and we sort of just said, oh, that's great. That's exactly what we want. So we implemented the same RFC that they published. And it's streaming, which means that we don't need to have the entire files in memory in one big buffer in order to, work on the file. So what we can do is we can actually read it in a little bit at a time from your drive and then encrypt it as we go. And so there's this huge pipeline that's going on. So first we read it in from your disk, then we encrypt a piece of it, then we feed it into WebTorrent, which produces hashes of the data that it's consuming. And then in parallel, that entire pipeline is going up to the cloud and uploading to our storage systems as well, because we want the link to work even if you close your browser. So we also store a copy of it for 24 hours so your link works. So that's all happening in parallel. And at the end of that, you end up with this metadata file, this torrent file that describes like what is in that share link. And then we encrypt that as well and upload that to the cloud. So what the cloud sees is we have this set of encrypted files that you've uploaded to us, and then we have this metadata file that's also encrypted. That means we can't see the file names or even like the sizes of any of the files or anything like that. It's just all in this big blob. And that's basically what happens on the uploader side. Any questions?
I do have a question, but I'm not sure exactly how to ask it. You said that there's a pipeline, which I understand, is take the file, read it in from the operating system, right? Mm-hmm. As you're getting the file read in, you're creating the torrent for it. Well, I guess the order of operations is what I don't understand. You're doing 3 things. You're torrenting it, you're encrypting it, and you're uploading it to your cloud servers. You said those are in parallel?
Torrents first.
Or what order does that?
First, we have to encrypt it. And then after that, we take the encrypted data that's coming out of that stream and we upload it to the cloud and we feed it through a thing that creates a torrent file. So all that thing does is it just sort of reads the data in and then hashes it and produces this list of hashes. Okay. That's what I mean by create a torrent. It's not actually sharing it with anybody yet. It's just producing the metadata file that describes what you're sharing.
And that torrent file isn't really ready for sharing until it has the entire manifest, right? It has to have all of the information before it's actually useful.
Yes. This is one limitation of torrents that we probably switch away from WebTorrent at some point, but for now it was the sort of quickest way to get something working in a secure way. But that is one limitation that we have to sort of deal with. Is a torrent is immutable, which means it can't change, which means that all the files have to be read into it. And then when you're done, then it's sort of finalized and you can't add files to it easily. You can't remove files from it. It is what it is. And if you want to make even any change to it, all the hashes change. The whole thing has to change, which means you got to read everything in again. Mm-hmm. So it's not very good for like modifying. That is one limitation of our designer now.
Why would you, just curious about because I have a side question to this, but why would you go through the encryption and then upload to your 24-hour hot seat, so to speak, and then not actually web torrent it first? Like, why wouldn't your client essentially, your cloud essentially be essentially a client to the web torrent?
Well, we could do that.
What's the limitations there? Is it simply just speed, or is it simply? I just wonder why the reasoning is for that. And then also later on,
great question.
Does your long-term or your 24-hour storage act as a client of? And I'm probably not speaking perfect web torrent terms, so correct me where that's necessary. But like, does that end up being one of the places that you pull from? So you said swarming. If you've got 5 people out there, does your 24-hour hot seat act as one of those people or act as one of those endpoints?
Yeah, it's great questions. Totally great questions. So the reason that we can't just have the cloud storage be a peer that downloads the files is that we're using Backblaze for our storage backend. They have this thing called Backblaze B2, which is kind of like Amazon S3. It's just a place to stash some file data. And we could like put stuff into those buckets like ourselves. But what we do for efficiency and also for cost reasons is we just give the client, the uploader, we give them a key that they can use to directly upload into Backblaze from their browser. And so that prevents us being in the middle of that. So they have a key that we give them that like authorizes them to write into a specific bucket, a specific folder in our Backblaze storage, and they upload all the data into it directly from their browser. So for that reason, it just has to use plain HTTP because I mean, Backblaze doesn't understand torrents. So the client has to just upload it into there. We could make it go through us, but like why introduce extra steps? Why do we want to have all that bandwidth going through us and have our bandwidth costs go even higher for no gain? So we just tell the client to do that. And then your other question was like that on the downloader side, does the downloader treat the cloud, this Backblaze cloud, as yet another peer? And it does. So that uses this thing that torrents can do called the web seed, which is basically a peer that is an HTTP server. So it's not speaking the torrent protocol. It's just a server that has some files on it, but your torrent client can treat it as a peer. So it can be like, oh, that's a peer that has everything. It has the whole file already torrented because it's sitting on a server there.
Yeah.
And then it can just treat it as yet another peer. So maybe, it gets some data from these peers and then it sees, oh, these peers are kind of slow. Let me go grab data from the server peer. It's a big hybrid model where it can get some from the server, some from the peers, depending on the network conditions that it's experiencing.
That's a pretty cool feature. So take us to the receiving end now. You went to wormhole.app, you put a file in there, you got your URL immediately, right? Let's say it's a 10 gig file, max file size. And so you're sitting there, you're still uploading it, but you sent me that link right away.
Mm-hmm.
I go post that link into my browser. What do I see? Stand by, we're downloading it.
Yeah. So first thing is that the URL contains two pieces. It contains the room ID is what we call it. It's just an ID for the files that identifies the files. And then it contains that secret key that's not sent to the server. So you make a request to the server for that room ID. It tells you, yeah, there's a room here, but I'm not going to tell you anything about the room until you prove that you have the key. Even though everything, like I said, is end-to-end encrypted, you could imagine like we could have designed it so like if you show up and you say, hey, I know there's a room with this ID, give me the files for it, please. We could have just said, sure, here you go, because we know they're encrypted. We're not worried about your data getting out there. We don't want to even give a copy, even of the encrypted files, out to random people. So we add this extra layer of security where you as the downloader, you take the secret key that's in the URL up there, you take that, and you derive a new key from it. So this is a way to sort of take a key and make a sub key. And how do I describe it? It's basically all you need is that main key, and then you can always get to the sub key. You can always deterministically produce the same sub key. But given the sub key, you can't go back to the master key. So what you do is
one-way hash.
It's kind of like you can think kind of like that. Yeah. There's no way to tell that they're related either. They're completely unrelated. So as far as the person looking at the two keys can tell. And so then what you do with that is you show that to the server, and the server, by the way, the uploader did this originally. The uploader produced the subkey and told the server the subkey. And so now the downloader does the same thing. They produce the subkey, and then they can show that to the server, and the server's like, you must have the master key. So I'll go ahead and I'll answer all your API requests. So you need that to do anything. We call it a reader token because it sort of authorizes you to do all the sort of, you can read basically everything about the room if you can prove that you have that token or that subkey. So then what that means is we're not going to answer anyone's API requests unless they actually do have the true URL. But we also don't need, as a server, we don't need the URL to know that we don't need the key to know that you have the key.
Yeah,
kind of.
You got the room ID plus this sub key.
Mm-hmm.
Is this formalized? Is this like a thing that has a name, or is this something y'all came up with?
It's just called deriving a key from another key. I'm not sure there's another name for it, but that's how we call it.
So I have my room ID and my derived key as the requester.
Mm-hmm.
And if I don't have that derived key or it doesn't match, you're not going to say anything to me, like, GTFO or whatever. And if I have the sub key, the uploader person, they had both the private key, which is in the URL fragment, and they created the sub key as well. And since those are deterministic, they're the same. But you can't go from the sub key back to the master key. So you're still on the server side. All you know is this is the person that is trusted. You don't know anything else. And you can't actually decrypt that information, even though I can, because I have the
You have the master key. Yep, exactly.
Well, that's cool.
Yep.
So then let's say the file's not there yet though. So I've proven to you, hey, Faraz sent me this URL. I got the key right here, the sub key. And you're like, hey, this is the room. You got the sub key. What's up? But the file's not ready. Is it just like, while one, sleep for a second and check again, or what happens?
Yeah, it's kind of like that, actually. I'm not even kidding.
Because that's how I would do it.
Yeah, it checks every 5 seconds
Okay.
to see if. So right now this is another limitation from using torrents that we're going to work around once we switch to something that's custom. But right now, like I said, we need that full metadata file. We need that torrent file in order to start doing anything, because that's just how torrents work. You need to kind of have that. That tells you how to make requests and how to validate that file data you got back is what you expected. So the downloader is sitting there waiting for that encryption process to finish on the uploader side. So it needs to fully read everything, encrypt it. And that doesn't take that long. It takes maybe a minute at most if it's 10 gigs. So it's not too bad. But during that time, that the downloader is just sitting there waiting for the link. The nice thing is the link works. They can click the link. They don't got to worry about, the link isn't ready or something. The link is ready. It's just the browser's going to sit there waiting for that torrent file. And once it's available, then the server provides it to them, and then they decrypt it locally using the master key that they have. And now they can look inside and be like, these are the files I'm going to download. So now at that point, we can show the user in the UI, we can show them the list of files that they're going to be able to download. And at that point, they can also start to connect to the sender using WebTorrent. So it's a peer-to-peer connection. They can connect directly to them and start to download stuff. And meanwhile, the uploader is still maybe uploading stuff into the cloud, but who cares? Because we're connected directly to the person with the files, and we can just get whatever we want right away.
The cloud's just a backup in that case, right? It's just meant to be once it's fully uploaded, if that peer goes down, then the cloud becomes the primary.
Exactly.
Mm-hmm.
Yep. And then all the requests that the downloader makes from the seeder are all for encrypted data. So the data needs to be decrypted as it comes out of the torrent. So everything inside there is also encrypted, so that you got to basically feed it through that. There's a decryption stream that can kind of decrypt the data. And we support sort of decrypting at any point too, which is really cool. So that means that we can have a video tag on the page. And if you seek to halfway through the video, that causes WebTorrent to realize, we don't need the pieces at the beginning, we need the pieces in the middle. And your browser will make requests for those pieces that it knows the video tag needs, and it'll get the encrypted data. And that encrypted data is halfway through the encrypted file, and yet we can still figure out how to decrypt that based on how it's designed.
Interesting.
So you decrypt it from the middle, because sometimes some encryption doesn't work that way. Some encryption is just
Front to back.
Start at the beginning.
Yeah.
Start at the beginning. Yeah, you can't jump into the middle, but we can jump into the middle and then decrypt it and then play it back for you. And that's all done using a service worker, which is another kind of cool trick. So we basically, what we do is we make a video tag and make the source of it, instead of being an HTTP URL for an actual server on the internet, we make it a specific URL that we know that our service worker is going to intercept. And the service worker sees that and it's that's a request for some data from this torrent. So it intercepts it, and then it basically provides exactly what the range that video tag is asking for. And so that means that you can sort of seek around, and it'll just magically sort of make the right range requests. The service worker will see those ranges. It'll ask the main page to say WebTorrent, hey, get me these ranges. And then WebTorrent will either use the cloud or use the peers or whatever and get those ranges, provide it back to the service worker, and the service worker feeds it back into the video tag.
This is
That
crazy.
makes sense.
So the service worker
Yeah.
is like a proxy between your video element and your HTML and your web torrent.
Correct. Yeah.
Got you.
Because see, the video tag is designed. There's two ways you can use the video tag. You either provide a HTTP URL. That's the normal way. You've probably used it before. And the other way is this thing that was designed for YouTube style adaptive streaming. Do you know what adaptive streaming is? It's when the video quality changes and you're watching Netflix and then suddenly you get it lowers the quality or it raises the quality. That's a thing that these video streaming services needed. And so they made a special API where you can sort of, if you're Netflix, you can sort of monitor how the download is going. Netflix doesn't just do video source equals, whatever TV show. It doesn't just do video source equals some URL and that's the whole episode of whatever you're watching, right? They do something fancier. What they do is they use the fetch API to fetch a little chunk of the video, right? And then they monitor the speed of that. Oh, is that going well? Is that slow or is that fast? If it's going fast, then they can be all right, the next piece we ask is going to be higher quality because this person's internet's fast enough. We can actually ask for a better quality piece for the next 5 seconds of this video. So then they ask for a better quality one, and then they need a way for the video tag to sort of stitch the different qualities together. This is called the media source API. And it's just designed to let these services basically do this thing where you can kind of like take different MP4 files and sort of make them seamlessly play as if they were one. And even though the details of the file are changing, the resolution's changing, the quality is changing. So that's one way we could do it. We could have done that and sort of use that same API to sort of get these blobs of video data and then feed them into the video tag with like an API where we just say, here's the next piece, here's the next piece. But the problem with that API is that it expects the files to be in a very specific like format. You have to kind of produce the MP4 files in a very specific way with specific options that you pass to FFmpeg or whatever you're using to make your videos. And most files that you find on the internet, like random videos that are on your computer, are not going to be designed in this specific way for streaming. And so that means that if we try to use this approach, it kind of fails. And so that's why what we need to do is we want to use the first approach where we just do video source equals and then HTTP URL, because then the browser can just sort of treat it like any other file that it finds on the internet. It can just sort of make requests for different parts of it. And then all we got to do is be the service worker and just intercept those requests and be like, here's the data you need. And then we don't have to do anything. We don't have to do anything special. We don't have to convert your file. We don't have to process it. We don't have to tell you, well, we can't play that kind of file. So we can support anything the video tag supports. Even like MKVs and like weird .move, dot whatever, I don't know, all the different extensions that the video tag supports. We don't have to have like special code to process different types of files or anything like that.
That's cool. So that service worker approach lets you treat it like a URL, but you're still doing the client-side decryption without you ever having to know any of the metadata about the file that's actually being transferred.
Yes,
that's
correct.
Cool. Okay.
And we do it in a way where the URL that's requested is like, it's a random ID. So the way it works is the video tag has like, it says like / download stream or whatever thing that we're going to intercept / and then a random ID. And the service worker sees that request and then it asks all the open Wormhole tabs. It says, which one of you was responsible for this URL request, this random ID? And then whichever tab was responsible responds and says, I was, and here's the data. And what's cool about that is if for some reason the service worker fails and it doesn't intercept that request, if it's, I don't know, somehow that request makes it to our server, which we really don't want that to happen. But if it does, the server's not going to have the file data anyway, because the URL is going to 404 because it's a fake URL designed for the service worker to intercept it. But what's cool is even if it makes it to the server, the URL just contains a random ID that means nothing. So it doesn't leak your file name. It doesn't leak anything. It's just like, someone's service worker failed. This doesn't happen often, but it can, and we just want to design it so that even in the failure mode, we don't learn anything about your files. Anyway, that's probably a lot of stuff, but does that kind of make sense about how it's all put together?
It's fascinating. The only thing I'm over here wishing is I wish I could just look at this source code and just grok it for myself. But you've gone partially open source with this one. I know you have some open source stuff on your socket dev org. Looks like the Wormhole crypto is out there and some other stuff you had to build for this. But maybe someday we'll have a peek at the source code. Until then, we'll just have to take your word for it.
Yeah, that is the part I wish I could give you a better answer for right now. I think, okay, here's the thing. I've open sourced everything I've ever worked on in my entire life, basically. It's all on my GitHub. And with this project, we wanted to make sure that it could be sustainable from the beginning because, when you're hosting tons of files, we're paying bills like to Backblaze for this stuff. We're paying for servers. And if we grow to be like 10 times bigger, then, that's going to start to be like a really meaningful amount of money that we're paying to host the service. And so we need to find some way to charge for something in order for this to be sustainable. So we're working on a pro plan right now that you'll be able to pay for that will give you extra features like larger files, customizable expiration time. So you could change it to be like 7 days or a month instead of just 24 hours, stuff like that. And then eventually we'll have maybe the drive features as well. And then you'll be able to store all your files for forever. I'm just not sure yet, like if open sourcing it would somehow like be a problem, like for the business.
Yeah.
I don't want someone to just like make a clone of it and then say, I don't know, it somehow causes the whole thing to not make sense. And then we have to stop working on it. So it's just at this stage where, you can't unopen source something. So we're just erring on the side of like, I open sourced the cryptography code so that the security community could take a look at it and make sure that there's no flaws. And we have a bug bounty program for that. So if you find any problems, you can make up to $1,000 finding bugs in that. And same thing with the Wormhole website itself. If you identify vulnerabilities in the Wormhole website, you can also make $1,000. So that's sort of the place we're at now. I honestly think we might end up just open sourcing it. It's just that I just wanted to be a little bit thoughtful about it and not just do it that way from day one. So I hope that makes sense. I just really want to make sure that it's a thing that we can keep doing going forward and not have this be like some kind of mistake from like some kind of strategic mistake that leads
I think you're playing it smart, honestly. I don't think you should feel bad about not open sourcing it. I think Jared is a developer and curiosity is what's asking for that, less about, hey, this should be. Because I think until you know this is secret sauce, it should just be secret sauce for you to figure that out. Because until you get the right partners involved, because if I haven't said it yet, I believe this thing could be a big thing. And I think it's a wise move to just ensure that the source code needs to be where it's at currently so that any future investment, anything that could happen for the company can happen without being hindered. And then if it makes sense to be community driven and open source, then that's still a vehicle you can drive because you've been there before. It's not unopened to you because you didn't open the door. So I think it's a wise move.
Thanks. Yeah. I mean, the only thing is I really wish that we could show people the code so they could have even more assurances that it's doing what we say it is. And, that's the part that I think we're going to try to solve by doing an audit where you can hire, we're going to hire like an actual team of people who know what they're doing, who are, do security audits for a living to take a look at the code. This is also what 1Password does because they're also closed source and they're security software. And so people need to know that the design, they do open source their design docs, which we've also done to some extent. We have information on our website about the design of the crypto. All the things I just talked about are all on the website. So the design is there, but the actual implementation itself, best we can do for now is to audit it, just like what 1Password does.
Well, you have told us your entire secrets. I mean, here on the show, you've told us exactly how it works, the entire workflow. It's a matter of having the smarts and the technology behind the scenes to put that together yourself. If somebody wanted to clone you, for example. So, I mean, the idea is freely shared here today.
Yep. Yeah, that's true. That is totally true.
Well, ideas are darn near worthless. It's all about execution.
That's right.
And so you've got a good head start on anybody executing on this. It's very technically impressive. I think as an application, you can't see any of that stuff, so like that's maybe the catch-22 with like simple products. It's like it's so simple for the end user and that's beautiful. That's your goal, right? Yeah. But then kind of like some of the stuff that's impressive, it's just like under the covers. And so super enjoyed you coming and sharing those things with us because we are curious and interested and impressed with some of the hacks and the solutions that you've put together to get this thing done. I definitely think it could be big as well. I'm looking forward to where you take it from here. This is not like your other side projects, right? This is like a company because you had some side projects that you said this is a side project. The annoying website is not something that you were ever trying to monetize, I don't think. But maybe as ransomware, get your computer back.
Yeah, for sure.
But you're taking this one seriously. And so I think that is wise as well, is to take it slow, make your moves strategically. And like you said, you can't undo the open source. You can open source it at any point, but you can't unopen source it once it's out there. It's like putting toothpaste back into the bottle. It doesn't work.
Yeah. And from a tech standpoint, it's been fascinating to hear about all of these hurdles that you've gone through to keep it web first and these really creative solutions for doing that. Things like the service worker and crypto on the client side and doing all of that. And storing the key in the, what'd you call it, Jared? The fragment, the web fragment part?
I call it the fragment identifier. I'm not sure if that's a technical term, but it's close.
Yeah, I think it is.
Okay.
Just really, really intuitive and really appreciative that you're showing the limits, and not showing the limits, but you're showing the capabilities of the web without having to just say screw it and go with the native app or anything like that. So that's really cool.
You're making Steve Jobs proud with a really sweet solution.
I can really appreciate too, for us, that you've been able to build upon what you've already put out there before.
Yeah.
Like this isn't zero. You're not starting from zero with this one. You're sort of layering on the things you've already given out there freely in open source. And you're also layering on your knowledge base or personal knowledge base to build this next big thing. I think that's really admirable. So congrats on that.
Thanks. Yeah. I'm working with two really cool people to build it out. So it's also like much more of a team effort than the other things I've worked on in the past. So, cause it's a real company. And so the two people I'm working with are John and Alex, and they're both really great. Like it's fun to work. It's fun to be on a team and, have another level of seriousness to a project and have it be a company instead of just, a side project. So that's been a really nice change of pace too.
So shout out to John and Alex. Thanks for letting Faraz skip stand up today so he could be here with us.
That's right.
That's all of our time. In fact, we probably spent more time than we usually do, but there's just so much to dig into. Plus, you can't stop a good Apple rant. Let it happen. Just let it happen. So we hope you all enjoyed that as well. Wormhole.app is the website. Faraz is hiring. Where's the contact there for people who are interested in getting involved, maybe from a hiring perspective? Where do they go?
So the company is called Socket, and our website is socket.dev. So if you go socket.dev, you can see there's an email there for hiring. We're looking for JavaScript and security experts. So if you're a JavaScript wizard or a security wizard, I guess the thing we put on the website is if you can make computers do things they're not supposed to do, then get in touch. So
there you go.
That's what we're looking for.
Sounds like a fun job to me. Adam, thanks for hanging out with us. Nick, it's always a pleasure. That's JS Party for this week, and we'll talk to you next time. If you're listening to this on your Changelog++ feed, you may be wondering why there's another 25 minutes left on the runtime. Turns out Adam, Nick, and I hung out before the official show began and chatted about all kinds of stuff. GitHub Copilot, GPT-3, Andy Weir books on Audible, Vim, of course, NeoVim, TypeScript, of course, The Secret of Mana, and other randomness. Here's a money quote from Nick.
I think we're going to get to the Citadel at the end of time, and we're going to see that the quote-unquote man behind the curtain of AI is just going to be a big Vim macro.
If you aren't on Changelog++, check it out. It's our membership program where you can directly support our work, get closer to the metal with bonuses like this one, and make the ads disappear from all of our podcasts. Learn more at changelog.com/++. JS Party is produced by myself, Jared Santo, and our music is provided by Breakmaster Cylinder. We are brought to you by Fastly, LaunchDarkly, and Linode. Next up on the pod, Emma Bastian and Nick Nisi welcome Kent C. Dodds for a deep conversation all about React. Stay tuned for that one. We'll have it ready for you next week.